Students, we have an empirical formula lab today.
Yep, another marvelous small lab coming your way. This one is empirical formula. Okay, so what we're going to do is try to find the simplest formula, the empirical formula, when magnesium metal reacts with the oxygen in air. We'll end up making magnesium oxide. Okay? But first, what we're going to have to do is get a couple of mass measurements. So this time we're going to heat the magnesium in a little steel cup called a crucible. And we'll want to know the mass of the crucible before we start.
Okay.
Okay, so we got that. And we're going to want to know the mass of the magnesium metal before we start.
That's magnesium, huh?
It is magnesium.
Good. Mass of the magnesium.
Yep. And so we just want the magnesium then to lay in our crucible, so I'm just going to coil it around. Actually, I should probably do it down here.
So the magnesium is going to react with the air. How come it's not reacting with the air right now?
Well, that's a good question. I wonder why. Well, there's no doubt the magnesium and the oxygen in the air are in contact with each other, but also the temperature is just not high enough to cause that reaction to occur at any sort of a rapid pace.
So it would happen if we let it sit around long enough.
Maybe. I mean, iron, if it sits out, we all know it rusts, it reacts with the oxygen in the air. And it doesn't necessarily have to be heated at all for that to occur. But with magnesium, I think we'd be waiting an awful long time to see it react with oxygen in the air. So,
yeah, a lot of metals, if you heat them up, they react with the oxygen pretty fast.
And actually, the magnesium will combust. It'll catch on fire. A lot of metals will combust when they react with the oxygen. You ever seen the old-time cameras that they used to use, and they'd have an old flash bulb, and it'd go poof, and you see smoke come out? That was actually a piece of magnesium metal igniting, and it gives off a brilliant white light. And so they're using it as a flash bulb.
Are we going to see the magnesium burning now? I'm kind of hungry for some burning.
Probably could.
Oh, I hope so.
I hope so. So I'll put.
We got the mass of that, yeah.
Okay,
So what did you just do? What do you got there?
Oh, I just when I was talking,
yeah.
just coiled it around a pencil, so it just lays in the crucible.
Yeah, so you can
Little bit.
expose more of the metal to the oxygen, right?
So we'll drop it in the crucible, and we're just going to heat it like crazy. We got out a bigger burner. Now, if we're lucky,
there it is.
you could actually see it maybe catch on fire in the crucible.
Yeah, it'll take a few seconds for that crucible to heat up. I mean, when it gets hot, it is impressive.
I mean, the bottom of the crucible is going to get red hot.
Yeah, it's getting there. Oh yeah.
I don't know, do they use magnesium in sparklers?
Yeah, I think that is magnesium.
I think it is. If you've gotten sparklers for 4th of July, or if you've seen them, it's little chunks of magnesium igniting. Okay, the bottom of the crucible is red hot, Mr. Moore.
Oh, yeah. So you get that magnesium hot enough, and it will.
There it goes.
Oh yeah. Crusting over.
Yep. So once it hits that high temperature, it really starts to react with the oxygen. And we'll be forming a magnesium and oxygen containing compound. Maybe we should light a strip of magnesium just so they can see it burn.
Yeah, that's a nice idea.
That's usually.
Yeah, burning magnesium is brilliant. You'll enjoy it. So Mr. Hevel has just a strip of magnesium with the safety goggles on.
Yep.
You're not going to hold that with your hands, Mr. Hevel?
Well, normally I put it in my teeth, but
Yeah, okay.
we're trying to be a little safer than we
Uh-huh.
normally do.
All right, check that out. That's burning magnesium. So good.
Yep.
Look how bright. We tell everybody not to look directly at it. It's like it gives off some ultraviolet radiation.
Yeah.
And it is very bright.
Yeah, you
Not
see
good for your
spots.
eyes, seriously.
You
Yeah.
see spots after that.
Yep. And that's what's left. That really is what's going to be made in our crucible, too. You can see
Right.
the piece that's unreacted.
Yeah, see,
And
it's
then
like-
the rest of it is just
turns
that.
into ash.
Right, yeah.
Let no magnesium go unreacted.
That would be irresponsible.
It would be. I can get all of it. Oh.
What's going on in here?
Yeah, now unlike the last lab, the potassium chlorate lab we did, when that reaction was done, it was obvious. The oxygen stopped bubbling out. It turned back into a solid. This reaction's not quite as obvious.
Uh-huh. You can see it's still reacting.
Yeah. So I don't know, do we want to let it go a while and come back, or
Yeah.
what do we want to do?
So we have our magnesium and oxygen product.
Yep. It's kind of a gray ash,
Yep.
kind of like what you saw on the table.
Mm-hmm. There's more white there.
Yeah.
It turned gray. But it doesn't look like the original magnesium, does
No.
it?
Think of rusting, right? When you have rusty iron, it does not look like the original iron.
Mm-hmm. So what do we have here? We have a mass of the crucible and the magnesium that was in there. That didn't go anywhere. It's
Nope,
still in there.
Magnesium's still there.
And so the mass has changed.
Mm-hmm.
What's in that crucible? What is contributing to that 17.055 grams?
Yeah, compare that to the original, crucible mass plus the magnesium.
Mm-hmm.
This is actually heavier.
So take those masses, see if you can find an empirical formula. We're looking for a mole ratio between the magnesium and the oxygen.
Mm-hmm.
I think we have the mass of both elements,
Mm-hmm.
magnesium
We
and the
can
oxygen.
get those, yep.
You have to do a little work for one of those, but you can do that.